Okay, what basically Sam was able to do was this. Turn it up for you. On the bottom, we have a Raspberry Pi 2, and then he's made up the hat that fits on top, and this has a microcontroller located here for supplying the signals out to the track from the control system. Now the control system is actually loaded onto the Raspberry Pi computer. So what he fundamentally did when he came out with this design was he eliminated a massive great laptop computer, and he condensed everything down to a package no bigger than a cigarette pack for your whole model train system. Admittedly, you do need a keyboard and you do need a mouse, and you also will need to plug in the cable out to a monitor. And that was one of the other things that really got me, was that I'm getting older and my eyesight's not as good as it could be. So being able to display my model train controller and a nice large 23-inch LCD monitor in colour is a lot better than the tiny little screens that you saw earlier on the Mobile Station 2. The other thing about it is that once you've got the system up and running, all you need is a mouse to walk around the board anywhere, and you can control it because I can see what's going on the large screen. So I think he's done an absolutely magnificent job in loading all this together. Now, to give you some idea of some of the other little tricks he came up with, here is the main chip. It's made by Toshiba, and it's called a full H-bridge motor driver. This can drive electric motors up to 50 volts. We're only running this at 16, so there's plenty of overhead capacity. And you've got the two wires, as you can see, coming out here, going out to the Macklin track. They just simply plug in. One of the other interesting things is, and one of the warnings he puts on the board, on the information, is that you should only use your power coming in, for your DC power coming in and go onto the desktop station board, the desktop station daughter board. You should not plug any power into Raspberry Pi, because you will blow things up. What he did was he introduced this little gadget here, which is a little voltage converter that drops the 16 volts down to 5 volts, and then through the pins over here on the board, it goes down onto the Raspberry Pi to power the Raspberry Pi. And of course, over here we've got the Atmel chip. Now this is exactly the same chip that's used on the Arduino computers, and it's a microcontroller. So what happens is that down in here you run the server, you supply information from the server up into the 18 mega chip made by Atmel, and that then supplies the information in digital form across to this little Toshiba chip, which then boosts the signal up from 5 volts in here to 16 volts and sends out the unusual copolar wave with the technical information out to the decoders on the locomotive. But that was an absolutely fantastic way, and typical Japanese miniaturization at its best, I think, utilizing what's available. Now, he was making these available in a kit that you could actually solder together yourself, or for an extra 10 euros or 15 euros, you could buy a fully built up board. For a total cost of 60 euros, including the programming done inside the chip, I felt this was far worthwhile investment. Now, bearing in mind that a Raspberry Pi 2 here in Australia was selling for, an international price was $35 US. In Australia, that worked out to be $55 Australian. So that's a relatively cheap system. And of course, I already had the switch mode power supply to supply power. I needed a keyboard, so I purchased this combination keyboard and mouse, which then talk to the Raspberry Pi through this little Wi-Fi dongle. And I've set it all up. Now I do have another Wi-Fi dongle for communication with the network, but I'm using that when I'm just doing Google searches with Chromium. But for my train control, I'm using what I call a closed loop system, where I just use the keyboard and the mouse talking into the Raspberry Pi, and that the Raspberry Pi is then sending the browser page out through the HDMI Wi-Fi HDMI connector out to the monitor and displays the browser page on the monitor. Brilliant system, simple, and it really works well. Now you can, of course, as I mentioned in another part of the video, you can set this up so that it's actually part of a network. So what you would have to do is, as you're establishing the software and everything into the Raspberry Pi, you actually set that up with an IP address, talking to a modem router somewhere in your office or in your house, in your workshop, and then you can use your smartphone or your iPad to talk via the Wi-Fi modem router and then get through access to the Raspberry Pi. So then you can pick up an iPad or a smartphone and walk around your model train set, and you could control it off the screen of your mobile phone or your iPad. Now the other thing that really got me once I started to realise just how good this system was it opened up another range of model locomotives for me. Mechlin, being German, is very Eurocentric, although they have produced some model locos for the American market, but they tend to be diesel locos from the 1950s through until the early 1960s, and they tend to be full width cabs. Whereas current generation American locos tend to be more of this design, where you have the operator's cab at the front, which is full width of the chassis, as you can see there, but at the back it's quite narrow, which gives the driver good visibility down either side so that he can actually see what he's doing when he's working in marshalling yards, or what's going on with the train behind him without any difficulty, without having to look through a rear view mirror. He can actually have a turnaround and peer out through the back window of the cabin. Now these particular units, to build a Mechlin that way, it's impossible because of the way they've set up the design of their decoder cards inside the locos. This particular one is actually manufactured, and I give credit to MTH in the United States. They realised there was a big market for Mechlin in the US, primarily because there's a lot of US servicemen have been over to Europe serving since the Second World War, and there is a number of train enthusiasts there. They brought back Mechlin to America and got enthusiastic. So what MTH have done is produced a range of locos where they put the centre skip, the Mechlin type skip or pickup shoe, in the centre of the loco, and this is all designed to run on DCC. So I now have the ability to use anything in the MTH catalogue, simply because it's all set up to run with the Mechlin C-Track with the centre pickup pins for power or for the signal coming into the loco. So I've got the best of both worlds. I've got the ability to run anything with DCC as long as I have a centre pickup, and I've also got the ability to run with the complete range of the Mechlin Motorola locos with that sort of decoder fitted to it, be it an MM2 or an MFX or an MFX Plus. Now I think we should go down and have a look in the workshop at the system up and running, just to show you how easy it is to get it started. I will say I'm using an older generation board, and one of the things I also have to say to you, that if you happen to buy a new one, you will find that the version in here is not r1-94 on the Atmel 18 mega chip. It'll be version r1-7, and that's the current generation we're up to and utilising. Yasan has been very good. He has actually sent me a copy of the hexadecimal file for the r2-17, so I can actually burn that hexadecimal file onto another chip that I've purchased. Just haven't got around to it at the moment, because I'm basically having too much fun running my Mechlin train set with both Mechlin and MTH logos. It's terrific.